We're going to look at the domain of a function or a relation. The most important word here is domain. What does it mean? And let's have a look at a definition. It's the set of all values that go into a function. Another variation on this definition. So it's also the set of all x values that are valid for the function, all the x values that make sense. Looking at some examples here, we could look at a set of ordered pairs just to begin with, and let's say we've got 3, 4, we've got 4, 7, we've got 5, 10, and we know we often, with ordered pairs, often identify x, y like that, the first being the x, the second being the y, and we could look at that as something that a rule creates, and for example y equals 3x minus 5 would create that rule. All the possible x values here, if there are none other, that's all the x values, and so the domain for that function would be this set. So it's simply just a set of all the x values. A domain can both be restricted or unrestricted. Sometimes that's called maximal when it's unrestricted, or implied. They mean the same thing, maximal or implied. Restricted means that it can only have certain values. Perhaps that could be a restriction there that you only have 3, 4 and 5 possible, or it just might be the only ones we've listed. We can graph this. So if we have some graph here, the domain would be all the possible x values. So if that's the x-axis, that would be the domain across there. That's how it might look graphically. By the way, all the possible y values are called the range, and for this one here, that would be the range. Let's look at some other examples here. For y equals 1 on x, what would be the domain for that? Well, we can't have 0 on the denominator because 1 over 0 is undefined. It's a big no-no, and dividing by 0 has no meaning. So what we've got is all real numbers except 0. So that could be written like that. Now I'm just going to rewrite that last one again. If we had y equals 1 on x, and I said it could be all real numbers except for 0. There's another way of writing that too. So you could write as we just had, or you could alternatively write domain equals R. So domain equals all real numbers except for 0. Otherwise you'd have this endless list, wouldn't you? Because real numbers are infinite. What about another example? What about if we had y equals 1 on x minus 1? What about that one? Well, x can't equal 1 because we will end up with 0 on the denominator again. So we could write domain everything except for 1. Another example, what if we have a different sort? Here we have y equals 9 minus x squared. Okay, so x can't equal positive or negative 3. Pause the video and have a look at y. So again, we would write domain. Domain does not equal plus or minus 3, so positive or negative 3. So all real numbers apart from positive or negative 3 are valid. The last one we'll have a look at is this number line here. So the domain for this one's shown graphically, so let's write in the domain. The domain is all real numbers. We can tell by the solid line that it's that case there, and it goes from negative 3 inclusive with the full dot to 4 exclusive because we've got the open circle there. This is domain.